Hey, this is Mr. Ward, and I'm going to do a video about the standard form and applications that would apply for that. Now, the standard form you've run into, of course, by this point, which goes ax plus by equals c. And you might notice this is a product, a times x, plus another product, b times y, and that equals some value. So this is particularly useful when you have situations where you might have to add a couple of products to get a value. And so here we are going to the store and you have $300 to spend on candy. How awesome is that? You need to get nasty gummy bears, which are $2 per pound, and delicious dark chocolate truffles, which are $5 per pound. And then it goes on to ask you, if you buy 54 pounds of nasty gummy bears, how many pounds of dark chocolate truffles can you buy? Okay, delicious dark chocolate truffles, I should say. Now, the first step here is, of course, to organize this into some sort of equation. Now, $300 is how much you can spend. And how much you spend on gummy bears depends on some unknown number of pounds. It's $2 for each one, but we don't know how many pounds you're going to get. And how much you can spend on dark truffles depends on how many pounds of dark chocolate truffles you get. So we can figure out how much you would spend on the gummy bears by multiplying $2 times the unknown number of pounds. And for chocolate truffles, $5 times the unknown number of pounds. So here's what we can do. We can say that, okay, so start off by setting x to equal number of pounds of gummy bears. Okay, and y equals number of pounds of chocolate truffles. And what this allows you to do is set up two products. 2 times x plus 5 times y will equal the total amount you will spend. And since you have $300 to spend, we can put that together and have that equal 300. So we say 2x, that's how much, $2 per pound times x pounds of gummy bears, plus 5y, $5 per pound times y number of pounds of delicious dark chocolate truffles will equal $300. 2 times x is an amount of money. 5 times y is an amount of money because dollars per pound times pounds is dollars. And dollars per pound times pounds is dollars again. So let's see what we have. Let's turn that on. And there you have a graph of that equation. 2x plus 5y equals 300. Now, you may be wondering, well, how do I know which is x and which is y? In this case, it does not matter. You might want to make a practice for the purpose of Laser Cannon Battle Commander using the first thing that shows up in the first variable that shows up in the story as the x and the second one as the y. But in this case, neither of these are really dependent on the other one. The whole gummy bears pounds and chocolate truffle pounds are essentially interdependent in this case. So formally speaking, it's not quite a function, but it will still pass the vertical line test. There is a relationship between gummy bears and chocolate that is 2x plus 5y equals 300. So you might notice we have two rates in this situation here. I'm going to take you over to the spread, this nice little flow chart that I created. And this was developed by students with me in a previous previous year. So is there anything like a rate in the story? Well, $2 per pound, $5 per pound, those are rates. Okay, so yes, then we say, are there two rates? Well, yes, there are. There's two different rates. So let's try standard form. So the flow chart leads you to standard form in this case. And the reason it does is you can have the two rates. One will be times x, one will be times y. There are variations on this theme where maybe instead of 2 rates, the variables are rates, and maybe X and Y are the rates, and you have numbers of pounds for one and numbers of pounds for the other. But essentially, you have a setup where it's a product plus a product equals some value. So let's go back to that Desmos over here, and let's deal with the question at hand. So once we have a model, we can plug in some values. So we are proposing that if you buy 54 pounds of nasty gummy bears, how many pounds of delicious dark chocolate truffles can you buy? Well, here's what you do. Since X is pounds of gummy bears, you replace X with 54. 2 times 54 plus 5Y equals 300, and then we just solve for Y. Okay, so 2 times 54 becomes 108. So 108 plus 5Y equals 300. And you might see it's making this horizontal line. This horizontal line is actually telling you what Y would be, 38.4 pounds. But let's go ahead and use our algebra tools to solve it. We subtract 108 from both sides. This 108 goes away, and we're left with 5Y equals 300 minus 108, which is going to be 200. And I'm sorry, it's going to be 192. Okay, and now we divide both sides by 5. So Y is going to equal 192 divided by 5, and that is 38.4. So we can get 38.4, or 38 2/5 pounds of delicious dark chocolate truffles if we buy 54 pounds of disgusting, nasty gummy bears. Okay, now you might notice that this graph includes negative values for X and negative value for Y here. So we probably ought to restrict this. So I'm going to go ahead and do that. I'm going to say that I can either restrict X or I can restrict Y. I'll say X is greater than or equal to 0. And here's a thing you can do, by the way, on Desmos. We can set up another restriction. I'll say Y is greater than or equal to 0. Now, an interesting thing about this is that we actually don't have to spend all $300. We could spend less than $300. So you could make this into an inequality. And we would say, instead of equals, we would say less than or equals. And now you have a model for all the possible combinations that you could get. Any point on here that's within this shaded area would give you a possible combination of X number of pounds of nasty gummy bears and Y number of pounds of delicious dark chocolate truffles. So any point within this and on this line here would be possible within the parameters of you have $300 to spend. Okay, I hope that helps a little bit. I'm going to give you, I'm going to create one more story, and I'm going to challenge you to figure out an equation for yourself. So here's a new situation. It'll be, okay, so you are mixing some granolas. Okay, this is a classic type of word problem you'll find in textbooks and standardized tests. Okay, you are mixing granolas. Okay, you can buy Fancy Pants granola for $8 per pound, and cheapo Hardbola granola for, we'll say, $1.50 per pound. Okay. And you are going to spend $50. We'll say $50. Okay. So, and we can add a question afterwards. Right now, let's just come up with an equation. So first, I challenge you to pause the video and come up with an equation for that. Well, you've paused the video. I will go ahead and turn things off for the previous situation. Okay, so hopefully you have now come back from coming up with your equation, and perhaps here's what you came up with. Since it's $8 per pound for the fancy pants and $1.50 for the cheapo per pound, we can say $8 per pound times X number of pounds of fancy pants granola plus $1.5 per pound times Y number of pounds of cheapo Cardbola granola is going to equal $50. And then, of course, you might have gone ahead and restricted it and said X is greater than or equal to 0. Let's make that a 0. And maybe you further restricted and said Y is greater than or equal to 0, because you know you can't get a negative number of pounds of granola. And then maybe you decided, instead of making it an equation, maybe you decided to make it an inequality. And that would be cool too. Maybe you said this. So it's less than, notice, oh wow, when I didn't say less than or equal to, it's a dashed line. But when I say less than or equal to, now it's a solid line. So all of this zone is a possible XY combinations for fancy pants granola and cheapo Cardbola granola. Okay, so now we have a model for this. Now we can ask a question. So I'll ask a question and you see if you can come up with the answer. How much fancy pants granola can you buy if you buy 31 pounds of cheapo Cardbola granola? Okay, so I'm encourage you to pause the video and see what you can come up with. Hopefully you have paused the video, and what you came up with was, copy this. Let's make it an equation here. So make that an equation. And since we're getting 31 pounds of the cheapo, we replace the cheapo pounds variable of Y with 31. And there we have actually the number of pounds of fancy pants granola we can get. This vertical line will actually tell us 0.438 pounds. Well, let's go ahead and work it out. What's 31 times 1.5? That's 46.5. 46.5. And then we can subtract 46.5 from 50 and actually subtract it from both sides. So we're left with 8x on the left because we got rid of the $46.5 that we're spending on the cheapo stuff. On the right, 50 minus 46.5 is going to be 3.5. And now we divide both sides by 8. So x is going to equal 3.5 divided by 8, which is 0.4375. And you might notice this answer is a rounded version of that. So that's how many pounds of granola we can, of fancy pants granola, we can buy if we bought 31 pounds, this 31 pounds of the cheapo Cardbola granola. All right, I hope that helped you a little bit, and I wish you the best on your level 6 problems.